Have you ever wondered how we actually tell an Arduino what to do? In this third lesson of our Arduino for Beginners series, we are going to explore the two main tools we use throughout this course to program our boards: the Arduino IDE and the Mind+ platform. The Arduino IDE is the official coding environment used to write and upload programs to Arduino boards. Mind+, on the other hand, is a beginner-friendly platform with a drag-and-drop block interface, perfect for kids or anyone just starting out. We will explore both platforms in this lesson and write our very first program, a simple sketch that turns the built-in LED on and off every second. And the best part? Both platforms are free and run in your browser, so there's no need to install anything complicated. Sounds good? Let's dive in. When the Arduino team built the first boards, they also had to develop a software to control them. That's where the Arduino IDE came in. Now, if you never heard the term IDE, don't worry, it stands for Integrated Development Environment, a fancy name for a place where you write code, check for errors, and upload it to your board. Think of the Arduino as a simple computer, kind of the one inside your phone or your car's media system. It's designed to perform small tasks like reading data from sensors, controlling LEDs or motors, or sending signals to other devices. More specifically, Arduino is a microcontroller, a tiny computer on a single chip with a processor, memory, and input-output pins all packed together. But here's the catch: microcontrollers don't do anything on their own. They need instructions, and those instructions come in the form of code. Just like your smartphone has apps that tell it how to take photos or play music, we need to write a program that tells Arduino what to do, like blink an LED, read a sensor, or spin a motor. Now, computers only understand zeros and ones, binary code. A 1 means on and a 0 means off. But writing in binary would take forever. That's why we use programming languages like C++ to communicate with the board. A programming language is nothing more than a set of commands in English designed to give instructions to a computer. There are thousands of languages and each one has its applications and pros and cons. The IDE helps us write code in a human-readable way. Then it takes the code and translates it into machine language so the Arduino can understand it. Let's take a look at the Arduino IDE. Open your browser and go to arduino.cc. Click on Products, Arduino IDE, and you'll see options to download it for Windows, Mac, or Linux, but we'll skip that for now. Scroll back up and click on Go to Cloud Editor. Note, you may need to create an account or sign in. Do that first. Once you're in, you land on the Arduino Cloud homepage. In the top right corner, click Create New Sketch. You'll now see the coding interface where we write our first program. Let's take a look at what is already there. As you can see, the IDE created something. This is the basic structure of any Arduino program. In the beginning, you can see two asterisks inside two forward slashes. These mark the beginning and end of a comment. A comment is a text we put inside our code that will be ignored by the machine. In other words, it won't be converted in binary code. We generally use comments to explain what is happening so other developers can maintain our programs. To start out, let's write down something like this. This program will turn on and off the built-in LED of an Arduino board every 1 second. Lesson 3 of the Arduino for Beginners series. That's nice. Now let's keep going. The next piece is the setup function. I won't dive deep about what is a function because I will do that on lesson 6. For now, you need to understand that the setup function must contain code that sets up our board. In other words, it must contain the initial configuration of the board, like each pin will serve as input or output, communication settings, and so on. This piece of code is executed only once right in the beginning. The next part is the loop function. Here, we must code everything that the Arduino should perform continuously, like reading sensors, displaying data, and so on. This function runs non-stop while Arduino is powered up. Now that you understand how the code is structured, let's write down our program. First, inside setup, write this: pin mode LED built-in output. This setups the LED pin, which is pin 13 on most Arduino boards, as an output, meaning we are going to send electricity out of it. The command pin mode tells the board how to use a specific pin. The first parameter is the name or number of the pin, in our example 13. The second is the mode we want it to operate, either as input or output. Next, go to the loop function and write digital write LED built-in high, delay 1000, digital write LED built-in low, delay 1000. This is what each of these commands do. Digital write is a command we use to turn on or off the flow of electricity from a pin set up as output. The first parameter is the name or number of the pin, and the second one is either high or low. High activates the flow, while low stops it. The delay command pauses the execution of the code during a specified amount of time. It gets time in milliseconds only, so delay 1000 means pause the execution during 1 second. So, what is happening inside the loop is keep sending signals from the LED built-in pin for 1 second. After that, stop it during 1 second. Then repeat this process indefinitely. Now that you understand what is happening, it's time to see it in action. First, plug your Arduino board into your computer. In the Arduino Cloud Editor, click on Select Device. If you don't see your board listed, a text will appear asking you to install the Arduino Cloud Agent. If that happens to you, click Download, install it, and refresh the page. Now, click Select Device again and choose your Arduino. Finally, click the Upload button, white arrow in green circle. The IDE will verify your code, convert it to machine language, and upload it to the board. After that, you should see the LED blinking on and off every second. Even if you unplug the board and plug it back in, the LED will keep blinking because the program is saved in the Arduino's memory. Pretty cool, right? Now let's try the same project using MindPlus, a beginner-friendly platform made by DF Robot, the sponsor of this series. Firstly, go to mindplus.cc, then click on Code Online, sign in or create a free account. If it's not in English, click the gear icon in the top right and select English. Next, we need to install the MindPlus device connector, just like we did with the Arduino Cloud Agent. First, click Connect Device. Download and install the appropriate agent for your operating system. After installation, refresh the page and plug in your Arduino board. Now let's configure the board. Click Extensions, go to the Board tab and choose Arduino Uno. You'll see a new set of dark green blocks appear. Let's build the Blink program using blocks. Drag this block and set digital pin 13 to high. Add a block that says wait 1 second. Add another block that sets digital pin 13 to low. And then add another wait 1 second block. Stack them in the forever loop and finally add a when clicked block. After that, click on Connect Device and select your board. Now, if you click the green flag, it will start executing the code. MindPlus will compile the block-based logic into real Arduino code behind the scenes and upload it to your board. Just like before, the LED will blink on and off every second. This platform is amazing for beginners because it lets you visualize logic without worrying about syntax errors. I recommend you spend some time here and try to code using these colorful blocks. By the way, if you are wondering how I got this beautiful black Arduino Uno board, it came in the MindPlus Arduino Coding Kit, a complete beginner-friendly set from DF Robot, who is sponsoring this 24-part series. DF Robot is one of the most respected names in the open source hardware world. Their online store is packed with sensors, microcontrollers, robot kits, and advanced boards for AI and IoT applications. They ship worldwide, offer great customer support, and their kits are very beginner friendly. If you are following along with this course, I highly recommend getting their kit. It includes everything we'll need for upcoming lessons. Big thanks to DF Robot for sponsoring educational content like this. And that concludes our third lesson. Today you learned what an IDE is and why it's essential for programming Arduino, how to write and upload your first sketch using the Arduino Cloud Editor, how to create the same program using MindPlus, a block interface coding environment, how both platforms convert your commands into real actions for your Arduino board. In our next lesson, we'll go deeper into electronics fundamentals, covering current, voltage, resistance, and Ohm's law. That knowledge will help you build more advanced circuits with confidence. In the meantime, make sure you've watched the first 2 lessons if you haven't already, and don't forget to subscribe to this channel so you never miss a class. Thanks for watching, and I'll see you in the next lesson.